So this week what we're going to be concentrating on are inequalities. So things that are greater than, less than, or we also have less than or equal to or greater than or equal to. And we're going to find that our discussion for equalities, right, how to solve an equation, is going to be very appropriate. And so all our equation solving skills are going to come to fruition as we try to actually solve inequalities. When are we greater than? When are we less than? So let's do a little bit of review. I think this was back in chapter 3. What we did is we know we can look at a graph and we can basically look at where these things happen. And it basically comes down to looking at three things when you're looking at a graph. Along the, remember, y is equal to f of x, right? So that's kind of a thing we have to recall. So if we have f of x equals to 0, that's the same thing as saying y is equal to 0. We're basically looking at the x-intercepts, all right? So locations we're actually crossing the x-axis. And then if we're above the x-axis, right, we're talking about f of x being greater than 0, or where are my y values greater than 0? And of course what we're looking for in that case are the x values where that occurs. So in this graph, right, we're looking for the inputs where the outputs are greater than 0. So it would look like we would be coloring that segment right there and that segment right there. So what I have in red, right, is where that's occurring. And then let me change some colors here. Hopefully this works. When we're talking about f of x being less than 0 or y being less than 0, then we're talking about this action down here. So where's the y values less than, or they're below the x-axis? And of course in blue we're talking about all these x values here and all these x values here. And so you can see that we're eventually going to have interval notation as part of our answers. And what's important is we have to basically, right, x-intercepts play a huge role, because where we have x-intercepts, there's kind of a transition from being negative to positive, right, positive to negative, negative to positive, positive to negative. So x-intercepts, where we're equal to 0, let me put that in black, where we're equal to 0 plays a huge role. So that's where I mean in terms of our equation solving skills playing a very important role. We can see the same thing happening here, right? So there's a location where f of x is equal to 0 on this graph, and then up above here, right, in red, we have f of x greater than 0, and we can see that's happening on that little stretch right there and this little stretch right here, all right? And where f of x is less than 0, we're talking about the graph being below the x-axis on that partition and below the x-axis on that partition. And what's interesting about this is we know that this is a rational function, and it looks like those transitions from being negative to positive, or positive to negative, or negative to positive, they're occurring at locations where not only are we talking about x-intercepts, but we're also talking about where we're undefined. All right, we know those to be our VAs. So there seems to be a transition in value around the x-intercept and around the asymptotes. So that seems to be what's going on as we look at this. Again, looking at the next couple of graphs, where does f of x equal to 0? Well, on this graph it's here, and it's here, and it's here. Right? So those are basically my x-intercepts. Y is equal to 0. Where are we greater, right? Where are my function values greater than 0? Where are we positive, basically? Well, we can see them above the x-axis. And again, it looks like that stretch right there, and it looks like that stretch right there. So we're basically transitioning, right? We're positive and positive, and then in some locations we're negative and we're negative. So f of x is less than 0. And so that would be in blue, that interval, and this interval right there. All right, so everything seems to be occurring, right? The change from positive to negative seems to be occurring, right, most frequently when my function is actually equal to 0. All right, and then we can even see the same thing here, right? There's an x-intercept at this location, right? There's an x-intercept at that location, and we also have a vertical asymptote occurring about what's like -4, and another one happening at about +4. And we see that the function is transitioning, right, around those areas where f of x is equal to 0, right, or where f of x is undefined. That would be, again, the VAs. right? And so we can see that we're positive, right? So on this part of the x-axis, our function is greater than 0, and on this part of the x-axis, our function is greater than 0, and right between these x-intercepts, our f of x is greater than 0. So we have 3 intervals along the x-axis where the outputs are positive. And then of course we have some intervals right here in blue and right here in blue where we have f of x less than 0 and f of x less than 0. So you can see all those transitions occurring where we have x-intercepts or where we have vertical asymptotes. There seems to be a change in value from the function being positive to the function being negative, and basically we can throw that in here, f of x equals to 0, and f of x is undefined. So all of these play a huge role in what's going on. And we can basically summarize, when we start solving inequalities algebraically, here's going to be our process, our step-by-step process. Step 1 is to actually solve the equality, right? So we're going to just put the inequality off to the side and find out where are we equal, right? So we're looking for x-intercepts, or we're looking where 2 graphs intersect, as you will see. And then step 2, you're going to basically take your solutions from step 1 and graph on a number line. And then step 3, what we're going to start doing is testing intervals in the inequality. All right, and then step 4 is we shade the intervals that make it true. And then step 5, I usually like answers. We're going to write our answer. We should see our answer, and we're going to put it in interval notation if I try to spell that. And we obviously will have some nice intervals. You can see the intervals occurring right in front of our face as we look at the graph. All right, so interval notation. So that's how we're going to do this. Right now I've used a graph to kind of set up that process. But once we start solving inequalities, like, let me give you a sneak peek of what's coming. So how are we going to solve this inequality here, right? We're basically going to solve the equality, oops, and I forgot something, and where we're undefined. I almost forgot that part. So we're going to find out what makes us equal to and what makes us undefined, right? Basically where our vertical asymptotes. We're going to take that data and place it on a number line, right? And then we're going to start testing the intervals in the inequality itself, making note of where things are true, and we should have a nice interval notation for that. So for example, to kind of wrap up the things we have here, if I had to solve this inequality, if we were solving f of x is greater than 0, then it looks like the inequality, let me 1, 2, 3, 4, 5, is basically from -5 to -2, and it looks like it's from 3 to infinity. Right, so that stretch of x values and that stretch of x values make the output greater than 0. And then of course the other ones, right, where is f of x less than 0? Well, it looks like from -infinity up to -5, and then it looks like from -2 to 3 is where that's happening. And of course the wild card is we know where f of x is actually equal to 0, right? That would be x equals -5, -2, and 3. So we've kind of analyzed our function on all different levels, all right? And so we know where we're above the x-axis, that's these guys. We know where we're below the x-axis, and we know when we're on the x-axis, or when we're equal to. And then the same thing would happen here, right? If we were solving f of x is a greater than 0, right? We would look, it looks like we have -infinity up to, where does that look like? -4, right? That asymptote. It looks like we're between -2 and 2, and it looks like we're over to 4 infinity. So that's where the intervals, where the outputs are greater than 0. Where are we less than 0? Well, it looks like from -4 to -2, union from +2 to 4. And then of course the other, we know where we're equal to, and we know where we're undefined. And so that's basically how our process will we'll visualize, right? Of course, we're not going to have the graph. We're going to have the algebra, and that's our process. So again, one more time, we're going to start solving inequalities by solving what makes me equal, what makes me undefined, set those numbers on a number line, test the intervals, make note of the intervals that make it true, and then write our answer. And the cool thing about this is this process works all the time. It's a process that algebraically solves all inequalities. You just have to be careful with your math, right? So that's why I want to start with section 5.6, and then we'll go take a look at some nuances in 1.7 and 4.5 later on. But I'm giving you a process, an algebraic process that works for all inequalities. So now that we've set that up, we need to go practice that process. So see you in some videos coming soon.